Hello, today I want to do a small exercise in recreative programming using the D programming language, which is one of my favorites. You can download it from this site, dlang.org, and I will be using the Raylib bindings for D, which are very useful. So let's create a folder. Let's call it live, because this will be an unbounded version of the game of life. We first initialize the project and add the Raylib dependency. And let's see, we need to, here it is, this command will add the binary files, the library files to the project. Okay. So let's open the folder with the editor. Okay, now we have, we don't have to, but we can copy this initial code to get started. Okay, let's see. This imports the library, verify the, the bindings, opens the window, set the target frames per second, and add a little initial game loop to use. Let's format the code a bit. Let's import the standard library of D. And let's see, let's change the size of the window and the title. And we don't need to draw any text yet. So let's comment this. And let's see first if it compiles. We will select the dev task. Okay. Run live. And this should open a window. It's taking its time, but it seems to work. Okay. Nice. So let's move this to the right. Okay. Now, what we need to do for an unbounded game of life is to first have some sort of representation for the positions that the cells will be in. Let's do this. So we have points, and the cells of the game can be alive or dead, and they will have a number of neighbors. And the board will be a dictionary containing cells and indexed by their positions. So with Raylib, we initialize a window, and then while the window is open, we begin drawing, we clear the background. We need to draw something here, and this is the main game loop. So before drawing, we need to input cells, and after we clear the background, we need to draw the board. So let's create those two functions. What is this squiggly? The naming conventions. Okay, to input cells, we need to use, let's make the draw board function so the compiler doesn't annoy us. So we need to check, is mouse button down? 0, I think, is the left mouse button, but let's use the correct name. This is surely defined here. Yeah. 0, 1, 2, etc. Okay. If we are pressing the mouse button, we need to get the mouse position. This, I think, will return a vector 2, which has float members, with which we don't need. We need a point with integer coordinates. Let's use a cell size bigger than a pixel. So yeah, this will return a vector 2. So let's create a point with the ground coordinates, because we need to cast to int this 2. So and add a cell which will be alive with 0 neighbors, but the name is incorrect here. Okay, the problem with this will be the information about the neighbors for the neighboring cells, but let's worry about that later. To draw the board, we make a for each cell in the board. The for each takes, in this case, a dictionary and iterates obtaining the first element will be the position, because it's the key, and the second will be the cell. So if let's draw a rectangle. This will use the position. The width will be cell size -1, and the color will be depending on whether the cell is alive. Let's draw the cell white. Let's use a dark brown for the dead cells. So I think this should work, but let's try. We are clearing to a color which makes, okay, this, we need to, this is a typo. So we are adding cells, nice, and they are all alive. Perhaps we will need to change the state of a cell. So let's use a static point to store the last position, and let's see, if pos is not equal, we will check if the cell is in the map, in the board. So let's we can obtain a pointer to a cell with this syntax. We check if a position is in the board. This returns a pointer to the cell if the key is in the board, or null if it's not. So if this pointer is not null, we reuse the cell, and if it's not, we add it to the board. But this let's see, this will, okay, this is this is repeating the, we will not, so only if we are pressing the button, or no, this is not working. We are having a problem here with the, when we draw, we need to remove half of the cell size, because to be able to click on the corners of the cells. Now it works. Let's check it with a bigger cell size. Okay, this works. Okay, now obviously the information about the cells is incomplete, because we don't have the information about the neighbors, which we will use to compute the next state of the cell when we process the information. So let's check first if the drag, the drag works. And we are, okay. Now the problem we have is with the lack of information. So we need to make we need to notify the neighbors when we create a cell, or when we change the state of the cell. So they know that there is a new cell around them. So let's see. Here we are notifying the neighbors after we set the new state, and here the new state is true. And for the neighbors we need obviously the information of the position of the neighbors. Let's see, -1. These are the 8 positions, the relative positions of the neighboring cells. Let me check again. Yeah, -1, 0, 1. So let's rename this because they are directions, and we need to add these 2 vectors. So we add the mixing linear, which is defined here in RayMath extension, which adds operations for linear algebra. So let's see, we have the neighbor position, and we do the same. If the neighbor exists, we notify the delta should, the delta which we notify the neighbors depends on the new state of the cell, and if not, we add to the board a dead cell with 1 neighbor. This should work. So obviously we are not we are adding the neighboring cells each time we add a cell. Okay, now we obviously need to process. Let's add. This will run when we press the space key. Let's call it step, and let's define here the step function. This will again we will use a for each loop, and let's see. First we need to remove dead cells that don't have any neighbors, and let's see. Here we need another element, the future state of the cell. So let's see. The rules of the game of life indicate, that if the cell is alive, it will be alive in the next generation only if it has more than 1 neighbor and less than 4. So this is okay. And if it's dead, it will be alive if it has exactly 3 neighbors. So with this loop, we compute the future state, and with another loop, we change. We need to use a reference here because we are changing the state of the cell, and here also. Now, if the future of the cell is not equal to the current state, we copy it and we notify the neighbors of the change. So this, what happens here? Sorry, we have the position here. So in theory, this should work. Let's no, this is obvious. Obviously, we are doing something terrible. Yeah, this is this is a problem. We are removing cells from here, but yeah, we should do this after we change the state. Now, let's see. No, let's comment this for now. No, it's something is not working. This is a problem. We were creating cells we are creating the cells. Yeah, this should work, but I'm not sure. Let's try. Yeah. Let's try something that we know how it works. Like, for example, yeah, nice. Okay, now we need a key to repeatedly compute, for example, the B key. So in this case, if we hold the B key, we execute continuously. Okay, nice. Let's try another pattern like this one. Okay, the problem is we are having too many cells that are yeah, let's see if this works. Okay, this should work. Okay, perfect. Now we have nice. Okay, this is working. In the next session, I will add camera controls to be able to pan and to make zoom to edit different zones of the board. Thanks for watching. Let me know if you have comments or questions. Please like and subscribe and consider supporting me using some of the links below. Thanks.